What's up, chemistry? So today what we are going to do is we are going to explore the concept of solutions. We're going to start the next chapter. You guys did pretty good. I updated all grades in Schoology, at least most of them, and we're still chugging along. This week is really cool because we're going to start solutions, and then we're going to start our project. It's not really a project; it's more a video or movie on deep waters. And what's interesting about deep waters is it just appeared in the news. I'll send out the preview of it. And this week on Friday, we'll start our movie over it. So it's super cool. Plus, you have a day off on Thursday, I believe. So that's awesome. All right. So, anyways, today we're going to start solutions. This unit is much easier. There's much less math than the previous one. There's just a bunch of terms, a little bit of math, like all chemistry, and it should be super good. Okay. So, a solution. When we're talking about solution, first thing I want to mention is that we are talking about a homogeneous mixture. So, this is compared to something that's heterogeneous. Heterogeneous would be like dirt. Okay, and homogeneous is it's gonna be a mixture. It's physically mixed together. It's not pure because you can have different levels. I always think Kool-Aid when we're talking solutions, where something gets dissolved in something else. So the thing you have to know is the solvent is the thing that does the dissolving. So this is found in the greatest abundance. And so if we're talking about a solution of Kool-Aid, which hopefully we'll be able to do that lab when I come back, the solute or the solvent is the water, and the other substance is the solute, the thing that gets dissolved. So this gets dissolved. Now, normally we think of solutions as just aqueous. Okay, so there's this word aqueous. Let me just mention this. We've talked about this before. This is when it has AQ. So AQ or aqueous just means that that substance is dissolved in water, and most solutions are. But there are a few others that are not, liquid solutions. Like for example, air is a solution. So in air, it's 78% nitrogen, and the rest is like oxygen, CO2, and a bunch of other things. Those things are dissolved in air. So anything that like disappears when it's like mixed together, that's a solution, and that's what we're talking about in this unit. Okay, so when we talk about solutions, oftentimes we'll talk about soluble. So soluble are things that are capable of being dissolved. Of being dissolved. Wow, that's bad. But that word's being dissolved. I have to practice my writing. And so something like, for example, we might say sugar is soluble in water, which just means they mix. Some things that are insoluble, this is no dissolve. And what we mean by that is like oil, which has a different nature. We often refer to it as like dissolves like. So polar things dissolve polar things or ionic things. And nonpolar things like gasoline is actually a solution of many oils or many types of oils, kind of. So soluble, it means you can. Insoluble, no good. It's not going to. And then aqueous, these are things that are dissolved in water. So this is that AQ as compared to solid, which solid, these are not dissolved in water. So the things that are dissolved in water, salts, like there's more than one type of salt, those things are all aqueous. And finally, alloys, these are solid solutions. So for example, when we made our penny, I don't know if you remember the penny lab, we made brass, and that copper dissolved inside of the penny. And so these are just down here. These are just examples. So a gas dissolved in a gas, that's an air solution, right? The solution of air. Carbonated water, like pop or soda, is gas dissolved in a liquid. You can have antifreeze with like ethylene glycol dissolved in water. So you can often see that the solvent over here is often water, but it doesn't have to be. It can be anything. It just has to be the one, in greater concentration or greater amount. Okay, now, so those are some backgrounds on it. So when we're talking about solutions, we're talking about things that dissolve in something else. They're homogeneous. Now, what we're going to do with this is we're going to talk about electrolytes. So when you put a salt in water, and this is probably since we spend most of the time in aqueous solutions, it's going to dissociate. And what we mean by dissociate is here's my solid salt. So this is my solid. And NaCl is made of ions. Those ions are Na plus and Cl minus. And these ions are actually attracted to water because water has a polar structure. So water comes in and like starts to pick off little pieces of the salt. And then it surrounds them in a process called solvation. But regardless, it doesn't matter. This process of this ionic salt, this solid, breaking apart into ions is called dissociation. And dissociation is when you split apart into ions present. Now, if you're associated with someone, that means that you're close friends or they were together, But if you're dissociated from someone, that means you split apart. You're breaking apart. You're not close to that person. So when you put a salt in water, it can be any salt. So a salt by definition is just a cation. So a cation would be positive ion, and an anion, that's a negative ion. So when you put these in water, they actually dissolve, and these actually form electrolytes. And so today we're going to talk about electrolytes and what those are. Oh, perfect timing. Oh my gosh. So electrolytes, this is, okay. So you've probably heard about this. Gatorade is definitely an electrolyte. Pedialyte, there's a bunch of a lot of athletes will worry about electrolytes because that can affect it. You can have too many, too little. But electrolytes, these are things that when you put them in water, they conduct electricity. And the reason why electricity there. So oftentimes you use what we call a conductivity tester where the lights will go on. And the reason why they contain ions which allow the transmission or conduction of electricity. So what you have to be able to do is understand what is an electrolyte and how to identify it. Okay, and I'll show you in the next couple slides. Okay, so let's get rid of that. Boom, boom, boom. Okay, now by definition, you can be an electrolyte where you conduct electricity, okay, or you can be a non-electrolyte where you don't. And you can also be a weak electrolyte where you kind of do. So here's how you can tell. If you are ionic and soluble, you are an electrolyte. Okay, and what I mean by an electrolyte or ionic is this has got to be made with a metal, one from the left, and a non-metal. So do you remember on the periodic table where to find the metals and where to find the non-metals? That's how you figure out if it's an electrolyte. Okay, and then so if it's a ionic substance and a strong acid, so there are 7 strong acids. I'm just going to write them out so you have them. So write these down because you're going to be asked about them. So they're HCl, HBr, HI, HNO3, H2SO4, and the chlorate ones, HClO3 and HClO4. Okay. So when you put these in water, you get lights out. There's tons of electricity when you test them. So the lights go all the way on. Non-electrolytes, these are all molecular things. So these are things that usually start with C. So they're all nonmetals. So for example, if I have CH4, that does not conduct electricity if I were able to dissolve it. A weak electrolyte, these are weak acids. So these are things that start with H that aren't the 7 strong. Okay, so we're going to try a couple, and I'll kind of talk your way through this. This takes a second at first, but it's not that bad. Okay, so when we put an electrolyte in, what happens? And so I'm going to do KCl. Okay, so the first question you have to ask yourself, is it a strong electrolyte? Is it a weak electrolyte? Or is it a non-electrolyte? And the way we know this is by how much electricity comes on. Actually, this is reverse. This is a non, this is a weak, and this is a strong, at least to the images. So I might as well use that since I have this. So when I put this in, this is a salt, and the K ions and the Cl ions are attracted to water. So they form K plus and Cl minus, and they form a lot of these. In fact, you get 100% of this. And since they're present, this totally conducts electricity and the lights go on. If I have something like HF, okay, so HF is what we call a weak acid. And you know that because it's not one of the 7 strong. So there are 7 really strong acids that are strong electrolytes. And so this is a weak electrolyte. And it breaks up into a little bit of this. Oftentimes what they'll write is they'll put a double arrow showing that it's like partial. And then finally this would be like methanol, which a lot of you did your projects on methanol. You did a nice job for the most part. And it doesn't break up at all. And the reason is it's no ions are present. So this would just be CH3OH aqueous. So it dissolved, but doesn't like break up into ions. And so to tell if it's a ionic salt or not, what you have to do is you have to look at the formula. Again, ionic. This is a weak because it's a weak acid, and this is a non. Usually non start with C. Okay, let's try some together here just to make sure. Okay, so how to identify strong? So if it's ionic, we'll just give you this because we're going to do this next. If it's ionic or 7 strong. Okay, weak. This is if it starts with H and it's not one of these, not 7 strong. So most acids are actually weak electrolytes. And then these are all nonmetals. So for example, if you asked about SO2 dissolved in water, it's a non. This is all nons. So it does not conduct electricity. Normally I would do a cool demo to show you guys this, and then, but I'm not there, so I can't. All right. So anyways, all right. Now, I think it's important to understand how things dissociate or break up into ions. So if it's ionic, and again, you look at it, and if this first one right here is a metal on the periodic chart, it's ionic. And so this is going to break up, and then the electricity, the lights are going to go on. If you have something like CaCl2, this also will conduct electricity because this is a metal, right? Metal, non-metal, ionic. So it'd be Ca plus 2 Cl minus. These are the ions that form in solution. And if I go back to that little initial picture, this is just the dissociation reaction. And this is just showing you guys, look, this is what happens if I put NaCl in water. I get tons of these ions, and this is what conducts electricity. But if I put this weak acid in, I do get a few ions, and I notice this is an acid because the H, it starts with an H, not one of the 7 strong. And so this one is a weak electrolyte. This guy's weak electrolyte. This is strong, lots of ions. Okay, and then if I look at non, when I put this in, and again, most of the time they start with C, all nonmetals, not an acid, doesn't start with H. This is a non-electrolyte, and no. So if I put sugar in water, nothing happens if I try to test it. If I put salt in water, the lights go on. I get lots of ions, and this is hard for students, but it's not that hard. Okay, so this is just telling you how you know. We kind of did this already. So ionic. We're looking for ionic. We're looking for weak acid, and then we're looking for starting with C. Okay, let's try some. This is the part. This is the meat and potatoes of the lesson, people. Okay, so you're going to look at this, and you're going to figure out. And I'm going to add another column. This is called a weak acid. Okay, so NaCl, it's ionic. It's an electrolyte. Salts, if you are dehydrated, they often put salts in Gatorade, to help replenish your electrolytes. This guy right here, methanol, this is totally a non, right? And the reason it's non starts with all nonmetals, non-electrolyte. Same thing, non. Okay, now this is an electrolyte. And I know this guy, HCl, is an electrolyte because it starts with H, right? All things that are start with H are always an electrolyte. They're either strong or weak, okay? This happens to be one of the 7 strong. You eventually have to kind of memorize those. Right now, just write them down. Just know what they are. This is a non. Again, starts with C. Strong electrolyte. Non. Again, starts with C. Okay, now this is an acid. They wrote it funny. This actually, if you write it differently, it starts with an H. So since it's an acid, it happens to be not one of the 7 strong. It is a weak electrolyte. All right, this is a weak base. We're not going to add too much to that, but it's a weak. We'll just kind of skip over that one. And let me scroll up a little bit. Oops, that's embarrassing. Scroll up. Oh, I think this is far. All right, so right here, this is H, starts with an H. It's actually a strong electrolyte. Okay, so in conclusion, I think that's it, yeah. In conclusion, what you should know is you should know that solutions are super awesome. And water is often the thing that dissolves many solutions. And that there are different categories of things that can dissolve. There are electrolytes, non-electrolytes, and weak electrolytes. what you should be able to do is just understand some initial stuff today. And so we're going to practice and finish this up with that little worksheet that you can do with your lab partner. It's online. Okay, that's it.